Hi, hello everyone. Very good morning, one and all. Welcome to the most comprehensive preparation app for all exams, BYJU'S Exam Prep. And warm welcome to the Maha Marathon class of GATE 2023 for CS aspirants. Suraj Mishra, Kaustub, Vitista Tyagi, Nishu Kumar. Good morning. Join the session quickly and mark your presence. Today, we are going to continue the practice on computer networks. Yesterday evening already we had practiced 45 questions of computer networks in the Maha Marathon. Today we will be practicing some more questions. Part 2. So Maha Marathon, which is covering complete syllabus in just 12 days for electrical, electronics, instrumentation, computer science aspirants. It happens at 10 a.m. as well as 4 p.m. 2 sessions, daily 8 hours marathon class. This is very beneficiary for 2023 aspirants. It definitely boosts your score. It definitely boosts your confidence. Right? Trivikram, Ayush, Ashwani, Nishu, Vitista Tyagi, Kaustub, good morning. So let me introduce myself quickly. I am Satya, research scholar with 15 plus years of teaching experience, mentored more than 35,000 students all over India. I am qualified in GATE, UGC NET, SET, and also certified by Cisco into networking and programming. My areas of expertise include programming data structures, algorithms, computer networks, computer organization and architecture, operating systems. Nishu, yes Nishu, today only one session. Kaushalya, Vivek, good morning. Guys, on 15th Jan, Abhinav Negi sir is taking a mega workshop for 2024 aspirants where he will be giving 7 success mantras to become beginner to topper at 12:30 p.m. So please do inform your juniors or your friends, whoever are preparing for 2024. It would be very useful session. Attend without fail. Now guys, you can avail up to 90% scholarship on all our preparation programs through the scholarship test, which will be held on 8th Jan, that is tomorrow at 12 p.m. So take this scholarship test, show your talent, show your performance and gain the scholarship. Okay, hurry up and register for this scholarship test, dear friends. And for the GATE preparation, GATE and ESE test series, where you will get full length mock test, subject wise test, around 4,000 plus questions you are getting with virtual calculator, so that you will get the feel of writing the real GATE exam, and also detailed analysis will be provided, where you are doing great, where you are going wrong, you can easily assess. So avail the test series and keep practicing. Okay. So guys, in marathon part 1, means yesterday session, we have practiced OSI, TCP IP model, physical layer, where we have got questions from encoding, different types of delays, topologies, medium and modes of communication. Data link layer, we have got questions from bit stuffing, sliding window protocols, error control, access control and MAC addresses. And also we have got few questions, maybe 3-4 questions from IPv4 protocol also. Right? So what is left? What we are going to practice in today, Marathon Part 2. We will continue the practice of this IPv4 protocol and then the very important IPv4 addressing topic, TCP, UDP, TCP Congestion Control, IP supporting protocols, application layer protocols. So we will try to practice the rest of the topics. Okay? Am I clear so far? Everybody? Please keep liking the session and please do invite your friends for this session. And guys, keeping the duration into mind, because such a long session is also difficult, what I have observed, what we have observed. So this session I keep only 40 questions. Every question will be given either 60 seconds or 120 seconds of time, and few questions are not given time because they are little complex. Once the question is displayed, the timer starts, and please attach the question number while giving your answers, and please make it as a habit to solve on the notebook, on the paper, not in the air. And please do maintain a comment log for wrong questions so that you can identify your mistakes. Okay, so are we good to go? Please type go. I want to see go message from everybody in the chat box. Okay, chalo, let's proceed with the first question of the day from the topic IPv4 protocol. Here is the first question, guys. In a packet switching network, packets are routed from source to destination along a single path having two intermediate nodes. If the message size is 48 bytes and each packet contains header of 3 bytes, then the optimum packet size is. What would be your answer? Come on, the time is running out. $50 seconds more. $30. 20. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Time up. So what's your answer, everybody? Option D. Okay. Suppose if the packet size is 4, then as the header is of size 3 bytes, let me change the color. As the header is of size 3 bytes, we can have 1 byte of payload and 3 bytes of header. We have total 24 bytes to forward, so 24 packets, because 1 byte only you can keep. So total 24 packets you have to make for transmitting 24 bytes. If you take 6 bytes packet, then 3 bytes of payload and 3 bytes of header. So for 24 bytes, 8 packets are required. And if you take headers packet size as 7 bytes, that includes 4 bytes of payload, 3 bytes of header common. So for 24 bytes we require 6 packets. And if you take 9 bytes packet size, that includes 6 bytes of payload, 3 bytes of header. So for 24 bytes total we require 4 packets. As with the packet size 9, you can send total message in less number of packets. Definitely the optimum packet size would be 9 bytes. Okay. Chalo, let's proceed to next question. Question number 2. Host A sends an IP datagram to host B. Both are on different networks. Assume that no error occurred during the transmission. When the datagram D reaches host B, which of the following IP header fields may be different from that of original datagram D? Nishu, you have given the right answer. You are asking again. Nishu, 24 bytes payload I have to send. So in the option 1, only 1 byte payload I can keep in every packet, so 24 packets. In option 2, I can keep 3 bytes of payload in every packet. So for 24 bytes, 8 packets are needed. In that way, option D can transmit total 24 bytes in just 4 packets. Because 6 bytes of payload you can keep in every packet. So in 4 packets you can send complete message. Hence that is the optimal size. Okay. So which may be different? Yes. TTL definitely will be different because both are on the different networks. So the TTL gets decremented when the packet is traversing from one network to another network. The TTL gets decremented. So TTL is different. And why offset can be different? What if any intermediate network cannot transmit this much packet size? Further fragmentation may happen. As here nowhere it is said DF is 1. Further fragmentation may happen. Then offset changes. And when any one field changes, checksum obviously changes, because checksum is calculated fresh at every network layer in the process. Right? So A, B, C definitely may be different. Source address, no. Source address will not be different. Okay, clear? Ayush, checksum is calculated for that IP header. You recall once, you have header checksum till protocol field, you have header checksum, right? So it will take, if same networks, TTL won't change. If you recall the header format, HLEN, version, HLEN, type of service, total length, identification, MF, DF, fragment offset, TTL, protocol, header checksum you have here. Isn't it? So it is taking 24 bytes. This is a 24, not 24 bytes, sorry. 8 plus 4 plus 4, 8 plus 4, 4, 8, 8 plus, okay, here version is not included, HLEN, yeah, 8 bytes. 8 bytes are taken. These 8 bytes are partitioned into blocks. Consecutive sum is done and final sum is complemented. That is how header checksum is produced. Now what we are doing, some value in these 8 bytes we are modifying. Some bits are getting modified because TTL is getting decremented or offset gets decremented. So checksum is calculated fresh every time. So when any value of this changes, checksum changes. Prajwal, I think I have answered. If same network, TTL won't get decremented. Okay, fine. Let's proceed to next question. Question number 3. An IP router with a MTU of 1500 bytes received IP packet of size 4404 bytes with header of length 20 bytes. The values of the relevant fields in the header of the third IP fragment generated by the router for this packet are. Okay, Nishu, Suraj. Last 10 seconds. 3, 2, 1, time up. Okay, What's your answer? Option A. Fine. An IP router received a packet of 4404 bytes. With IP header of length 20 bytes and MTU is given 1500 bytes. So this is the MTU. Maximum it can forward 1500. We know 20 bytes header is must in every packet. So more 1480 bytes you can keep in one packet, right? So to send this 4404 bytes, how many packets we have to do? 3 packets. First packet will have 1480 plus 20. Second packet also will have 1480 plus 20. So 1480, 2960. 4404 minus 2960. 1444 bytes of payload is left. So the third packet will have 1444 plus 20. Right, with that complete message you will be able to send. As it is the last fragment, MF will be 0. MF will be 0 because it is the last fragment. And what would be the payload length? 1444 bytes. And what would be the offset? Offset is giving the starting position. Till now, how much payload is over? 2960, 0 to 2959 numbers are. So offset would be having the scale factor of 8. So 2960 divided by 8, 370. Hence, MF should be 0, payload 1444, offset 370. Option A is the right answer. Clear? Okay. Next question. Question number 4. In an IPv4 datagram, the M bit is 0. The value of HLEN is 10. The value of total length is 400. And the fragment offset value is 300. The position of the datagram, the sequence numbers of first and last bytes of payload respectively are Nishu, don't give solution, just give answer. Hi Saubhagya Nayak, good morning. Quick. 40 seconds left. Ten seconds left. 3, 2, 1. Time up. What is your answer? Option C. Yes. As mbit is 0, definitely you can say the answer should be, the position of the fragment should be last fragment. So option B, option D, you can just rule out. Now, HLEN is 10. So header length will be HLEN multiplied by 10, multiplied by 4. This is 10 into 4, 40 bytes is what the header length. Then how do you get payload length? Payload length is total length minus header length. That is, total length is given 400 bytes minus 40, 360 bytes of payload we have. And given the offset is 300. Offset is 300. That means what is the starting position of this particular fragment? Starting position would be 300 multiplied by 8, 2400. And we have 360 bytes of payload. So 2400 to 2759. 360 bytes you have to count. So total 360 bytes we have. So the first sequence number is 2400. The last byte sequence number should be 2759. Hence, the right answer is option C. Okay? Ayush, all kind of people I have to keep in mind, right? Question number 5. Host A sends UDP datagram containing 8880 bytes of user data to host B over an Ethernet LAN. Ethernet frames may carry a data up to 1500 bytes. Size of UDP header is 8 bytes and size of IP header is 20 bytes. There is no options field. How many total number of IP fragments will be transmitted and what will be the content of offset field in the last fragment? Programming wala, for the array it is in place. Wait. It require extra array. Yeah, I think yes. Yes. For linked list it is in place. For the array it is not. Time up. What's your answer? C. A. Okay. We have 880 bytes of user data. That means it is the application data. So from application layer, 880 bytes coming. For that, UDP add 8 bytes header at a transport layer plus 8 bytes header is added. So altogether it has become 8 bytes of payload to the network layer. Network layer has to add 20 bytes of header. 20 bytes of header. So total number of IP fragments we have to count. And what is the MTU? 1500. So what you have to make? 1480 plus 20. This is what the max payload you can keep. Right? Now, in one packet 1480 bytes you can place. Then how many packets required for 8 bytes of message? So number of fragments would be 4 8s divided by 1480. Use the calci. You are getting 6 point something. So 6.0005 something means definitely 7 fragments are required. Kaustubh, UDP datagram containing 880 bytes of user data. It is given clearly. The datagram means it is having data plus header, okay. But it is clearly given it has 880 bytes of data. User data means application layer data. So minimum 7 fragments are required. So up to 6. How much payload in first to 6th fragment? Payload filled would be 6 into 1480 What is that? Triple 80 bytes. Now I want offset. So offset means this will be numbered from 0 to 8879 because we start numbering from 0. So the last fragment payload starting number would be 8880. So 8880 by 8, 1110. So the offset would be 1110 and number of fragments would be 7. Hence answer is option C. Okay. Question number 6. Okay. Consider 3 IP networks A, B and C. It's a big question. Quickly read the question. And I think you can see this diagram. It's 1 Mbps, 512 BPS. BPS or bytes? I think it should be bits per second. Kilobits per second. It is given. Thirty seconds left. Ten. Time up. What is your answer? Nishu, Suraj, Programming Wala, Kaustub. Top 10. Kausalya, Ayush Takar, Satya, Shyam, Rajwal, Saubhagya Nayak. Everyone. $220. Okay. Three networks ABC. Host A send message each containing 180 bytes of application data to host C. TCP prefix 20 byte header. This passes through intermediate network B. The maximum packet size including 20 bytes of IP header is given for A 1000, for B 100, for C 1000. They are connected by the BPS link. Okay. Assuming the packets are correctly delivered, how many bytes including headers are delivered to the IP layer at the destination for one message? in the best case, means no error occurred, nothing loss. Okay. Network A, network C, network B. This is how they are connected. Now, A MTU is 1000 bytes, B MTU is 100 bytes, C MTU is 1000 bytes. A has got 180 bytes of application data. To that, TCP prefix 20 byte header. So total 200 bytes of payload is coming to the network layer of A. And the network layer also add its header. So from A, how much can go at a time? 220 bytes packet. Can 220 bytes forwarded by A? Yes. MTU is 1000 bytes, so 220 bytes आराम से भेज सकते. Okay. Now B MTU is only 100 byte. So what B do? It will take this 220 byte. In this 220 byte, we know IP header is there. So it separate 200 byte and 20 byte separately, because this is IP header. IP header of A network layer. This is replaced. This should be replaced by B IP header, and 100 bytes is what the maximum transmittable unit. So 80 bytes payload and 20 bytes header you can keep, but you have 200 bytes of payload. So what I do? 80 bytes, 80 bytes, 40 bytes. I have to make 3 fragments. Here I add 20 bytes of payload. Here I add header, 20 bytes of header. Here 20 bytes of header. So altogether it is 100, 100, 60. So total you are sending 3 packets. Packet 1 100 byte, packet 2 100 byte, packet 3 60 byte. So total to the network C, how much is getting delivered? 260 bytes. So the answer is 260. Clear? Including headers, how much are delivered? That is the question. Okay, let's proceed to next question. Question number 7. Which of the following statements is true with respect to IP header? Quickly read the options and give your answer. 1 minute time only given for it. Last network का लास्ट पैकेट क्या क्या पूछना चाहते हैं आप? टॉप 10. अगर आप लास्ट नेटवर्क पूछना चाहे तो नेटवर्क सी में हेडर इंक्लूड होता, अगर वही डेस्टिनेशन है तो वो सिर्फ वेरीफाई करता, लेकिन कितना मिला नेटवर्क सी को वो है क्वेश्चन। नेटवर्क बी से कितना बाइट पूरा मिला, पूरा मिला के 260 बाइट का कंटेंट मिला ना, वो है सवाल। टाइम अप। ओके, which of the following statements is the true? The fragment offset is 13-bit and has a scaling factor of 8. Why? Because total we have 2 power 16 bytes of what we say, identification has a 16-bit. That means 2 power 16 bytes are possible. That offset is given 2 power 13 bytes. That is how you got the scale factor of 8. So offset is 13-bit correct and has the scale factor 8 correct. True. The type of service field determine the total number of fragments. No. This TOS field is combination of delay, throughput, reliability, cost. These 4 parameters. So as the name indicates, it is to inform or give like what I can say, it is to let the receiver know about sender's network configuration, more or less. It is not to indicate the total number of fragments, so this is false. Protocol field is of 10 bits. No, it is of 8 bits. Identifier field determine whether there are more fragments present in the fragmentation process. No, for that we have MF flag to know whether there are more fragments or not. Identifier field is helpful to identify to which segment the packet belongs to as the packets go out of order. So only option A is true. Okay. Question number 8. One of the header fields in an IP datagram is the time to live field. Which of the following statements best explains the need for this field? It won't require even 1 minute time, but okay, give your answer. Once I get all your answers, I'll end the timer. Why TTL is needed? To prioritize the packets, to reduce delays, to optimize throughput, to prevent packet looping. Undoubtedly, to prevent packet looping. I think everyone are aware of it. No explanation, no further explanation is needed for it, right? Can I proceed to next question? Question number 9. Which one of the following fields of an IP header is not modified by a typical IP router? Checksum, source address, length, time to live. Again, a straight question, simple question. Checksum, yes. When TTL or any field gets modified, checksum gets modified. Length, when further fragmentation happens, length gets modified. At intermediate routers, when further fragmentation happens, length gets modified. TTL, however, modify, but source address will not be modified. Okay, next question. The maximum number of IPv4 router addresses that can be listed in the record route option field of IP header is. It's a previous year GATE question. I think you all know how. We know IP address, particularly V4, length is 32 bits or 4 bytes. And where this record route option will be? This record route is part of options field. Options field length is 40 bytes. So 40 by 4, 10 IP addresses actually you can maintain. 10 IP addresses actually can be maintained in the options field. But which option we have included? Which option among options included? And for ICMP messages also comes with the options. 4 bytes reserved. Hence, if you take 4 bytes, 36 bytes left. That's how max 9 IP addresses you can maintain. In the record route option. That is how the answer is 9. I think everybody know this reasoning, right? It's not just knowing the value 9. Why? You are all clear. You already know this. If so, I am happy. Yes, ICMP messages are part of options. Okay? Yes, Ayush. 20 bytes fixed header, 40 bytes optional header. Then how you people have given 9, Ayush? Without knowing the reason? You just remember the value. That is not good for health. You have not given the answer at all. Acha. Ayush, one IP address length 4 byte, options field length 40 byte. Clearly I have written, no? So in 40 bytes, how many 4 byte value you can keep? 10 values you can keep. Record route means through which router the packet is going. All those router IP addresses are feeded. Like that, how many IP addresses you can feed? 10 IP addresses actually, because options has 40 bytes space. But options, record route is not the only option you have. You have multiple options in the that you can keep in that area. So what you have utilized, what these addresses are for the receiver to know, and for ICMP messages 4 bytes always reserved. So though 40 bytes there, 36 bytes only you can utilize for any other option. That is how 36 means 9 IP addresses you can maintain. Okay? Okay. Guys, before we proceed to next question, your favorite Rakesh Talreja sir is coming up with exclusive general aptitude session. In 15 hours, you can avail 15 marks. So complete general aptitude gets revised by this session. And do subscribe and stay tuned to get the notification about update. And Rakesh sir and Ankit sir together will be taking a non-stop maths marathon, so that in 2 days all maths syllabus you can cover, you can practice, you can revise. So these two are what upcoming plans. When they happen, at what time, what date, for every detail you have to wait and you have to stay tuned. Okay. Now, the king of computer networks, the king topic, the hero of this movie, IPv4 addressing. Are you all ready? Nishu, maybe routing algorithms I might not discuss in this, because I have got more questions of IP addressing, and I have just included couple of questions of routing algorithms. Maybe routing algorithms I could not cover, but please do revise. That is important. Okay. I could not cover it probably, but you people please do revise routing algorithms, because that is important. I have included just couple of questions, I believe. Chaliye, let us start IPv4 addressing practice. Congestion control is there. Yep. An organization has class B network and wishes to form subnets for 64 departments. The subnet mask would be 10 seconds left. Time up. Class B. So, network ID 16 bits. Given you have to form subnets for 64 departments. So, actually subnet ID requires 7 bits. Actually 7 bits, because for 64 departments 6 bits means you will get only 62 numbers. But here for this question it is compromised. Actually 7 bits, guys. So here 22 bits are non-host bits. So in the subnet mask, which is the complementary of wild mask, in the subnet mask non-host bits are ones, host bits are zeros. 16, 6, 22 ones, remaining zeros. So it would be 255.255.252.0. Yes, option D. Okay. Next question. The address of a class B host is to be split into subnets with a 7-bit subnet number. What is the maximum number of subnets and maximum number of hosts in each subnet respectively? Time up. What's the answer? A. C. Guys, again it is class B. So 16 bits for the network ID. Given subnet ID 7 bits. So 2 power 7 minus 2 subnets are possible. 126 subnets. And for host ID 32 minus 16 plus 7. 32 minus 23, 9 bits left. So number of hosts per subnet. Two power 9 minus 2, that is 510. So 126, 510. Arey yaar, what you learned? What concept you learned, Suraj? Huh? Even in the subnet ID also, the first subnet ID is the network ID. last subnet ID is for broadcasting among all the subnets. Like how you understand for the host ID, like how hosts are child for subnet, subnets are the children for network. The first and last subnet reserve, no, in the host portion. Similarly, in the subnet portion, first and last network reserve. Okay. थोड़ा अच्छे से सीखो बेटा. No comments on anyone I am doing. I am not pointing to anybody. Please don't take in that way. But ultimately, you are the one who have to learn and perform in the exam. So please make sure you are learning the complete concept in the right direction. Okay? Next question. A router uses the following routing table. Okay. Then, अरे एक मिनट रुको, पूरा क्वेश्चन नहीं है, just give me a moment. ओके, मिल गया क्वेश्चन, एक मिनट. Yes, here is the question. Okay. Solve it now. Please solve it now. 20 seconds left. Five, 4, 3, 2, 1. Time up. Satya, it is 16th question नहीं 13th question है. Okay, let us see. This is the routing table and this is the IP address we got. Means the router has got a packet. In that packet header, destination IP address is this. This router connects to Ethernet 0, Ethernet 1, Ethernet 2, Ethernet 3. Now the router has to decide to which Ethernet I have to forward this packet. How it decide? On this IP, apply the mask. Guys, applying the mask, we have to be smart enough. You have to do a little analysis. 144.16, all the destinations have it, and at last I have zeros for 3 destinations, 64 for 1 destination. And now if you see the mask, when you have 255 in the mask, when you do AND operation, IP and mask 1, when you do AND operation, what you get? What do you get? When you have 255, you get the same value. When you have 0, you will get 0. So it is matching with the destination. Yes. Similarly, IP and mask 2, when you do AND operation, you will get 144.16 and the last octet is 0, so you will get 0. Now you have to do 68 and 224 AND operation. So only these values convert into binary, no need to convert everything. 64 is 0100 0100. 224 when you do AND operation, this is what you are getting, 64. So is it matching with this given destination? Yes, matched. Similarly, IP and mask 3 you have to do AND operation. What do you get? All 3 255s 0, so you will get 144.16.68.0, even it got matched. Now IP and mask 4, when you do AND operation, first 3 255s you will get the same value, and the last value you have to do and in binary. 117 you convert into binary, that is 64, 32, 96, 16, 112, 5, 117. Now this is 64, 0, 1, not 64, sorry, 254. 1, 1, 1, 1, 1, 1, 1, 0. So do AND operation. You will get 0, 1, 1, 1, 0, 1, 0, 0. So this would be 116. So it is matching with the given destination? No, not matching. So it is matching with 3 destination IPs: Ethernet 0, Ethernet 1, Ethernet 2. So where we forward, we will always choose longest prefix match. Longest prefix match we choose. What is the longest prefix? In CIDR notation, if I write, this is /16, right? This is /19, this is /24. So which has longest number of ones? 24 ones in the mask for 3. So Ethernet 2 is given the priority. So the right answer is Ethernet 2. Okay. Question number 14. Suppose computers A and B have IP addresses 100.103.10.113, 100.103.10.91 respectively, and they both use the same net mask n. Which of the values of n given below should not be used if A and B should belong to the same network? Nishu, you solved or you just remember the answer? You solved this much fast. झूठ बोले तो थोड़ा मान लेना यार, ऐसा रहना। ओहो, ठीक है, ठीक है। Ten seconds more. Time up. What's your answer? So all are with option D. What do you do? The given IPs and all the masks you have to do AND operation. If they give the same result, that can be used. If they give different result, that can't be used. So this IP and A, when you do, you will get same. 100.103.10.0 and B also give 100.103.10.0 because 3 to 55 give the same value, 0 gives 0. Similarly, option B AND operation and A when you do 100.103.10.128 has MSB1, 113 has no MSB1, so you will get 0. And B 100.103.10.91 also don't have MSB1, so you will get 0. Now 192, when you do AND operation, you will get 100.103.10. Here we have 64 as common 1, so you will get 64. And B when you do 100.103.10. Here also 64. Now 224 when you do for the last, you will get 100.103.10.113 96. 113 you do, this is 113. 224 128 64 32 192 224. So you will be getting what? 96. But when you do AND operation with B, you have only 64. So these are not same. These are same. These are same. These are same. So this, if you use it, interpret A and B belong to different network, but we want they belong to same network, so this should not be used. Okay guys, someone may watch this later recorded, no? If I simply tick the answer and go, they may not understand. That's why I have solved it. Maybe you might be wondering, after everybody say the answer, why Sir is solving. Okay, fine. Next question. Consider 3 machines M, N, P with IP addresses so and so. The subnet mask is set for all the 3 machines. Which one of the following is true? Okay, in 90 seconds I'll end the timer for this question because you are fast enough. Time up. Chalo. This is the mask. So mask AND operation with M when I do, I'll get 100.10.5.252 and 2 I have to do AND operation. You will get 0. mask and n when you do AND operation. 100.10.5.5 has 1 in the LSB. 252 don't have 1 in the LSB, but 4 is what common for them. So you will get, if you want I can write 5 means 0 0 0 0 0 1 0 1. 252 means 1 1 1 1 1 1 0 0. So 4 is the common thing. So you will get 4. Similarly, when you do mask AND operation with P, they do have 4 in common. So you will get 100.10.5.4. So these two are equal. So N and P belong to same subnet. M belong to different subnet. DBR LSR important है ना sir? Nishu, yes of course important. I don't deny. आ सकता, वही बोल रहा हूँ ना, सिर्फ राउटिंग एल्गोरिदम्स क्वेश्चंस आप थोड़ा अपने आप रिवाइज कर लीजिए, ठीक है। मैं तो क्वेश्चंस इंक्लूड नहीं किया समय के कारण से, थोड़ा समय कम था, क्योंकि कल शाम को हमारा सेशन हुआ था, उसके बाद फिर एक पूरा क्वेश्चंस इंक्लूड करके एक ऑर्डर में रखने के लिए थोड़ा टाइम लगा, मेरे पास उतना समय नहीं था। राउटिंग एल्गोरिदम्स का क्वेश्चंस मैं सिर्फ 1 या 2 इंक्लूड किया था, लेकिन राउटिंग एल्गोरिदम्स अपने आप रिवाइज कर लीजिए, ठीक है। नेक्स्ट, an IP router implementing CIDR receives a packet with address so and so. The router's routing table has the following entries. The identifier of the output interface on which this packet will be forwarded is. Yes, Satya. See, even if I frame another question, I change the number. Practice is what required. So what number, it doesn't matter, no Satya, because when the model is same, numbers doesn't matter. I don't think you people will be remembering by adding the numbers of IP addresses and all. So definitely you will be solving it right now. Good morning Lalit Yadav. Do it quick. Forty seconds left. Last 3 seconds. Time up. What's your answer? Ayush 1, Saubhagya Nayak 3. Okay. Guys, mask is given in CIDR notation /12 /14 /16 /15. So this is 255.240.0.0. This is 255.252.0.0. It is 255.255.0.0, 255.254.0.0. Now, one simple analysis is all have 255s in the first octet, so you will be getting 131 when you do AND operation, and all the destinations are having 131, so you can divide. And all the last octets are having zeros in the destination, here also zeros, last two octets. So you just need to focus on the second octet. So 240 AND operation 23, 252 AND operation 23, 255 AND operation 23, you get a 23, 254 AND operation 23, right? 240 means this 23 this is 23. So when you do AND operation, you are getting 16. So it is matching with the destination 131.16.0.0. Yes, Nishu. 252 1111 1100 0001 0111. Here also you are getting 16 for 20. It is not matching. Not matching, right? 254 and 23. Zero 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 1 0 1 1 1. So this will give 16 plus 6 22. 0 0 0 1 0 1 1 0. This is 22. So it is also not matching. Okay, it is matching. It is 254 is last one. Achha. So we are having two matches. So we go with the longest prefix match. That is output interface ID is 3. That is okay, Saubhagya. Please carry on. Okay, sorry. Longest prefix match. /12/15. So /15 we go with. Yeah. 1. No, I was just focusing on Saubhagya Nayak message. 1. Okay. Next question. In the network, the fourth octet of the last IP address of the network which can be assigned to a host is last 1 minute. Thirty seconds more. Four, three, two, one. Time up. 126, 158. Okay, it's given /27. That means 32 minus 27. 5 bits are the host ID. So in 200.10.11.144, out of these 32 bits, only last 5 LSB bits changes. So 200.10.11. This is 144. 27 bits means these are 27 bits. This indicate net ID and subnet ID. These 5 bits host ID. So the first possibility is 00000. Last possibility is 11111. But this is reserved. This is given for the subnet ID. This is reserved. This is for the broadcast purpose. So the last IP address that can be assigned to host would be 11110. That can be assigned to host. So 200.10 200.11.100.11110. So what is this value? 200.10.11. This is 31. No, 30 plus 128, 158. So the last octet that can be assigned to host is 158. Okay. Yep. Next question. Consider 500 class A networks organized into 10 groups of 50 networks each. The subnet mask used by the interface should be. Time up. What's your answer? Class A networks. So 8 bits for the network ID. There are 10 subnets. So 4 bits for the subnet ID. So 12 bits ones, 20 bits zeros. That is what the mask. So 111111.1111 remaining zeros. This is 255.240.0.0. You might have taken this 50. That's why you might be wondering. But still, even for 50, you should get option B. Okay. Let's proceed to next question. Question number 19. The subnet ID of the given IP address is dash in decimal. Lalit? CD, how they can be correct, Lalit? Host bits should be zeros. Yes, what is the subnet ID of the given IP address in decimal? Time up. None has given the answer. Why? Ayush, I can't see your message. What is the value? I can't see. I can't see any of your answers. Acha. Fine. Our IP address started with 172. 172 comes under class B. Class B. Class B means, okay, you check yourself whether you have given the right answer or not. Fine. Class B means 16 bits for the network ID. So in /20, 20 minus 16, that means 4 bits indicate subnet ID. So in 172.148.152.117, these 16 bits represent network ID. Here you have subnet ID and here some bits have host ID. This is how many? 4 bits. So 152 convert into binary, 128, 16, 148, 152. So this is what 152. These 4 bits represent subnet ID. These and 117 together represent host ID. So subnet ID is equal to 1001 in binary, that is 9 in decimal. So the answer is 9. One 48 हुआ, 128, 16, 144. अच्छा, sorry. Okay. Yes, Nishu. Thank you. Okay. So you all have given the same answer. Fine. After this question, we will have a break. The last host address of network is Prajwal. After this question, we will have a break. The last host address of network is Time up. What's your answer? CCC. Yeah. /27 means 196.140.130. In 110, it is 64, 128, 64, 32, 96, 8, 104, 108. This is what 110. Here, these represents net and subnet IDs. This represents host. Right? So the last host address means these bits becomes 11110. So then it would be 196.140.130.011 So what is this value? 2, 4, 6, 8, 14, 16, 30, 60, 30, 32, 62, 64, 126. So 196.140.130.126. Okay. Good going. I think we have more 5 questions from this IP address concept. Let us quickly have the break for 5 minutes. Stay tuned. Be back after 5 minutes. Yes. Everyone, welcome back. Welcome back to the session. Am I visible and audible, everybody? Please confirm. Am I visible and audible? Am I visible and audible, guys? Now you can download our free ebook for GATE preparation by subscribing to our BEP YouTube channel. And also, we are conducting scholarship test. Tomorrow there is a scholarship test. You can avail that scholarship test to avail up to 90% scholarship. So try to circulate this as much as possible. And free GATE workshops we are conducting. So to get all these notifications, do subscribe to our BEP channel and register for this workshop and scholarship test by the link given in the description box. Okay. Let us proceed to next question. Which of the following are private IP addresses? Question number 21 on your screen. Which of the following are private IP addresses? Nishu says B and D. Okay. Time up. Guys, this is what the private IP address space. You can see for class A, when the IP address starts with 10, all the range of the other 3 octets is in the private IP address range. So this is private IP address, option D. And class B, if you look at 172.16 to 172.31, 16 to 31 only. So only option A, option C is not private IP address. And in class C, if you look at 192.168 to 192.168, if it starts with any other octet value you got, that is private IP address. So A, B, D are private IP addresses. Okay. Next question. The broadcast address of second subnet in a network with address 200.100.200.10/26 is. Good afternoon, Gmol. The broadcast address of second subnet in a network with address is. quick, option B. Okay. Twenty seconds left. Ten seconds. Time up. One 172.168. Sorry, 172. Yeah. You have to remember, Ayush. /26 means, and the given IP is a class C. So 24 bits for the net ID. Two bits for the subnet ID. So possibilities 00, 01, 10, 11. This and this, these two are reserved. So this is the first subnet, this is the second subnet. And we want the broadcast address. So host bits would be ones. Right? Okay, Gmol. Wish her a speed recovery. Take care of her. So 24 bits would be in the same way, 200.100.200. Subnet bit would be 10. Other bits are ones. So this would be 200.100.200. This is 63. This is 128. So 191. Option C is the right answer. Suraj, 00 we reserve for the net ID. Net ID means what do you give? 200.100. Means DBA ID. 200.0, no? 0 means this is having this. So subnet ID 0. So it's a DBA ID, not DBA, network interface ID. This is a DBA ID, broadcast ID. Okay. Next, question number 23. Suppose a node with IP address all hundreds wants to send a packet to itself. The source and destination IP address fields would be dash and dash respectively. It's a simple question, direct question. Time up. The right answer is option B. Source address would be same, but the destination address would be loop back address. When the packet wants to deliver to itself, destination address would be loop back address. Source address would be same. Okay? Source address because to whom it has to be delivered. The network layer should identify, no? Okay? Yeah. Next. Question number 24. Ayush, when you keep loop back in the destination, the packet won't even enter into the medium. From the network layer only, the packet is backtraced. So there is no need of visiting router. Guys, for this, no time limit I have given. So give your answer. What would be your answer? It's PYQ, of course. Given 245.248.128.0/20. 245.248.128.0/20. This is with the ISP. So /20 means 32 minus 20, 12 bits for the host ID. So total 2 power 12 minus 2 host addresses are possible. Right? In this half of this chunk to A, quarter to B, remaining ISP wants to retain with itself. So for a while let us neglect this minus 2. 2 power 12 by 2, 2 power 11 to organization A, 2 power 12 by 4, 2 power 10 to organization B, remaining with itself. So here 2048, 1024, remaining 1024. So total 4096. Just for easy calculation, I am ignoring that minus 2 for a while. So 20448 hosts means mask should be /21. 1024 hosts means mask should be /20. Right? So from the options you can eliminate option C and option D /22. 22. Here if you see, both option A and option B have the same. Right? And if you see, look at the destination for option B, both are equal. So every packet when the ISP receive, he apply the mask and it match with both the destinations. So he always prefix the longest prefix match. So if you prefer option B, all packets are routed to organization B only. All are routed to organization B only. That's why the valid allocation means in such a way if he do, no packet will go to organization A. That's why he will make sure the destination is different so that it would be a valid allocation. Clear? Okay. Next question.